So in this video, we're going to talk about what a series is. A series is basically just the sum of all the numbers in a sequence. So for example, if we had the sequence 1, ooh, that is not a great color, the 1 over 2 plus 2 over 3 plus 3 over 4 plus 4 over 5 plus 5 over 6. If we had such sequence, we can see that the first term of the sequence, just call it term, the first term of the sequence is equal to half, the second term of the sequence is equal to 2/3, and so on. And to summarize the sequence, we can actually say that any term in the sequence, so the nth term in the sequence, well, if the first term is 1 over 2, the second term is 2 over 3, we notice that the numerator is just equal to the term number, and the denominator is just equal to the term number plus 1. So we can say that the nth term is, and the sequence is just equal to n over n plus 1. And so if we were to continue counting, if we were to continue counting and we wanted to add up all of these terms within the sequence, then we use the shorthand where it's this big backwards E thing, and we say, well, we want to start counting from is equal to 1, and then we want to count up to when n is equal to 5. And so then we can call this n over n plus 1, and this is equal to exactly 1 over 2 plus 2 over 3 plus over 4 plus 4 over 5 plus 5 over 6. And this is equal to some number. What it's equal to, I don't particularly care about. However, it is equal to some number. Despite the fact that it looks like there are two variables in this, there is no variable in the series. Your n is what is known as a counter, and you basically use it to count each term. And so what we're most concerned with about series most of the time is whether or not it sums up to some number. I guess it will always sum up to a finite number if you're counting to a finite number. So for example, if you count from n equals 1 to n equals to 10 of n over n plus 1, this will also equal to some finite number. What we're more concerned about is, well, instead of summing it up to 10, what if instead now we take our sum to infinity of n over n plus 1? And we want to know, well, if I sum up an infinite number if I sum up all the terms in this infinite sequence, will I produce a finite number, or will this sum always be increasing, or will it always be changing? If this sum is on a finite number, then we call that converging. So if it's a finite number, we call this convergence. If it increases unbounded, or increases unbounded, we call this divergence. And if it does not exist, we also call this divergence.